Hi, I am Ranjan Kumar on Mathematical Mind online classes, and today we are going to deliver horizontal line test. So, do you know about the horizontal line test? So, horizontal line test means a graph intersect at only one point, right? That is a graph intersect only one point. So, today discuss here horizontal horizontal line test. Okay, horizontal line test today. So first of all, we define what is the horizontal line test, right? So here a function a function a function f is 1 to 1 1 to 1 if and only if every horizontal line intersect the graph of f in at most one point. Okay, that means graph intersect at most only one point is called horizontal line test. Okay, so if I say fx is equals to 3x plus 2, okay, 3x plus 2, that means if I draw the graph of here x-axis and x dash, y and y dash, right? So graph intersect at x is equals to 0. If I say make a table and here put x and y, right? So if I draw x is equals to 0, y is equals to 2, x is equals to 1, y is equals to 5, x is equals to minus 1, y is equals to minus 1 also, y is equals to here, y is equals to minus 1. Okay, so this is a very simple here. If I say if I draw here, this is the minus, here put minus 1 and here minus 2, minus 3, minus 4, here 1, 2, 3, and x is equals to here 4 and 5. Okay, and this one is if I say 1, 2, 3, right? So look at here. If I say if I draw the graph of line according to our table, so if I draw the graph, x equals to 0, right? X is equals to 0, then y is equals to 2. X is equals to minus 1, then y is equals to minus 1. Okay, x is equals to 1, then 5 here. So if I draw the graph look like this. Okay, so graph at x is equals to 0, right? So graph intersect at x is equals to minus 1, then y should be a minus 1, right? So look at here, the x-axis intersect at x equals to minus 1. right? That means the graph intersect at only one point, right? Graph intersect only x, the line intersect x-axis at most one point x is equals to -1. So that is this is called horizontal line test. This is very important, but I'm saying that the graph is the graph intersect. If I draw x is equals to here, if you draw the line like this, the graph intersect at that point. Here x is equals to 1, then here -1, right? And if I draw the x is equals to 1, then y is equals to also here. So I have drawn the three lines, but the graph intersect at x-axis here. If I x-axis intersect at x is equals to -1, then the graph intersect that line. So every point graph has unique. There's a no at most one point. So that is uh, that graph is one to one. Okay, so every time the graph intersect at one and only one point, so that this is the uh, one to one function, and the inverse function is exist. So the vertical line and horizontal line is so very important for the finding a inverse function or not through the graph. Okay, and we have to say the graph is increasing or decreasing, then we have decided and depend upon the vertical and horizontal test. Now come to the here. This is very important point I have discussed with the next question is gx is equals to x square minus 3. Whether we are telling you the x square minus 3 is not not 1 to 1, right? 1 to 1. Why? And they are not horizontal test defined, because here if I draw the graph, they have, if the vertical line is, the graph intersect look like this. If I draw x and x dash and y dash, that means graph is x is equals to 0, then y is equals to -3. That means graph is which is a passes from the -3. So and x is equals to 1, then -2. Okay, x is equals to 1, then -2, and -1 we will take here 2, right? Here if you take -1, then you got -2. Okay, and if you take also 1, they got -2. So graph is moving look like this. Okay, so every time the graph intersect more than two and two more points. Okay, so this is not one to one. You have visualized very easily that function is one to one. So you have using the graph and finding the solution. This is a graph is one to one or not. So basically we have to we show the graph every time the x-axis intersect the x-axis x-axis intersect more than one points, more than one point, one point. Okay, so this is not one to one. This function is not one to one. Okay, one to one, you understand? So this is very important for the all the students here, because the you find very the tough the how can verify that the graph is horizontal test or one to one. So without any calculation you will easily find out that graph is one to one or not. This is very simple. uh, we will find the graph is one to one or not. Whether one to one, the graph is not one to one, then the inverse function is not exist. Okay, so this is very simple concept about the function. So second thing is theorem. I define a theorem is increasing and decreasing, right? Theorem is says that the increasing and or a increasing or a decreasing function are one one to one or not. Okay, one to one, one two or one not. This is very simple, the concept here. So describe here. So first of thing it says a function that increasing throughout its domain, the function is one to one. Okay, so without strictly a function a function that a is function that is increasing throughout its domain is 1 to 1. That means if I say the function, you take a linear function, y is equals to fx is equals to 3x plus any type like 2. I have taken 3x plus 2. This function is 1 to 1 throughout. The reason is the function is uh, throughout increasing, right? Strictly increasing because they draw the line. If you this is the 1 to 1 not this function. If I say x and here x dash y and y dash, and the line which is the line passes from the x is equals to 2, then this is here the x is equals to 0, then y is equals to 2 look like this. The graph intersect at the x-axis at x is equals to 1. So this is the y is equals to fx is equals to 3x plus 2, the graphically, and this is the throughout increasing in its domain is equals to all real values, and its range is equals to f in range is equals to here y x minus 2 in terms of if you draw a range. So f inverse of x look like x minus 2 over 3, that is the range where 3 is not equals to 0. So this function is strictly increasing throughout this domain, and the range is 3 is not equals to 0. So except 3, they are all real values 0 to infinity, right? This is very important. So function is strictly increasing, and if the function is strictly increasing, then the function is 1 to 1 and defined on its domain. So function is whole real value, the function is whole real values that define. That's why the function is throughout is increasing and throughout the domain. The function is increasing throughout its domain, right? That's why the function is one to one as well as the inverse function is exist, right? This is very simple. And now we have to say the define other second one. If the function is decreasing, if a function is decreasing throughout this domain, then we say that uh, the function is throughout the domain defined, then the increasing. Now come to the exercise increasing. Next one is a function is a function is 1 to 1. A function is 1 to 1, and that is that is decreasing throughout its domain, right? Throughout the domain is is one to one, or throughout the domain, then the function is increasing, right? So a function is one to one. If the function is one to one, that function is decreasing throughout the domain is called the function is one to one, and then inverse function is also exist. That is, the if you say take any function, like if I show y is equals to negative x, right? Y is equals to negative x, then the function is decreasing throughout this domain. So that is equals to whole real number, means that negative infinity to positive infinity, right? So whole real number, and range is equal throughout its domain, means that if I take negative then become positive, and positive then become negative. So also minus infinity to infinity. That's So the function is decreasing throughout of its range, throughout the domain. So y and y dash, the graph which passes from the origin look like this one. Okay, this is the decreasing function, y is equals to negative x. The function is decreasing throughout this domain, then the function is one to one. And inverse function is exist. So we have to see the vertical test and horizontal test. So we have to also, the function is increasing and decreasing. Now now we have to find out the definition of inverse function. Okay, so first of all, definition of definition of inverse function, the inverse function, right? Definition of inverse function. Definition of inverse function: let f be one to one function with domain D and a range R. A function R, a function G with domain R and range D is the inverse of is the inverse of f, provided that the following condition is true: for every x in D and for every y in R. So y is equals to fx if and only if and if and only if x is equals to gy. That means that is f inverse of y, we know that gy. Okay, so here f, that is called x, yeah, that is the x. Okay, this is called inverse function. So this is do you understand about the inverse function? Inverse function is exist whenever function is strictly increasing or decreasing throughout its domain, then the function is increasing. Okay, then the function is exist, and then the inverse function is defined. So very important role of the function is in function, inverse function is exist. So horizontal line test and vertical line test are so very important for through the graph we have visualized the function is one to one function is defined, then the inverse function is exist, and the you directly we have to draw the graph and plot the graph intersect at most one point in its domain, then the function is one to one. If the function is one to one, and the if the graph is at most more than one point intersect of the line, then the function is not one to one, so stop, the function is not inverse is exist. So this is very basic concept about the inverse function. So we have to discuss about the theorem of the inverse function. So do you know theorem of the inverse function? Theorem of the inverse function. So this is very simple. If the function is one to one, okay, let f be a function f be a function, f let f be 1 to 1, 1 to 1 with domain, with domain D and range R. Okay, if G is a function uh, if G be the inverse function, right? G be the inverse function of f, if and only if both of the following, both of the following condition are true. Why true? First is, if I the compose g of fx, g of fx is equals to x for all x belongs for all x in for every x in D, for every x every x in D. Or second is uh, f of gy, that means they have x or sorry, this means y, means for every y in R. Okay, so then the function is exist and the function is defined. Now I give you some example and plot the graph. First of all, the first is first f then g, right? So if you plot the graph look like, if I they set a and here set b. Okay, so x and g of fx, right? So this is the operate the function f, so we come fx, and now they operate again g, then the g here, so b become g of fx, right? Now this is the domain D and range is R. So here second graph is, if you draw the second, this is the domain and this one is range. This one is range. So if I draw GY, that means draw the graph F again, and if you draw here to reach GY, so f of gy, got it? So now of domain and range of f and f inverse. So domain of f inverse is equals to range of f, and range of f inverse is equals to domain of f, right? This is so easy. So we say that f inverse of fx is equals to x for every x in domain of f, and if I draw f of f inverse x is equals to x for every x in domain of f inverse. Okay, you understand? Now we discuss about the some examples how can find the here. So I take y is equals to 3x minus 5, right? Then you find here f inverse of y. How can? So first of all, you move to the right side, both side adding 5. So y plus 5 is equals to 3x minus 5 plus 5. Now here if I draw y plus 5 is equals to 3x and both side divide by 3, then you will get 3x over 3. That means y plus 5 over 3 is equals to x. That is the f inverse of y, because in terms of y, and the same as we can say f inverse of x. So we put in place of x, you put x plus 5 over 3 is equals to x. That means inverse of in terms of x, right? So how can define f of f inverse of x is equals to identity or not? Okay, so this is very easy, and this is first of all this is very easy, so we check it, this is our solution is correct or not. F inverse of fx, if I put f inverse of 3x minus 5 is equals to 3x minus 5 plus 5 over here 3. That means you cancel out here, look like this, 3x minus 5 plus 5 over 3. This one is cancelled, so 3x over 3 is equals to x, and same thing is here, means that f inverse of x is equals to x plus 5 over 3. This is if I draw again f inverse f of f inverse of x, right? So f of x plus 5 over 3, that means 3 times of x plus 5 over 3 minus 5, that means 3 cancel. So you should x plus 5 minus 5 equals to x. So there is a reason we draw here. The graph is also important. So this is the example for finding an inverse function or not, and this is the exist or not. Okay, so did you understand about the concept of horizontal, vertical and inverse function? So next class we will try to discuss about the some examples. Thank you so much.